What if I told you a single sentence, just a few words, could completely break an AI model? Not just confuse it, but actually cause it to misbehave, hallucinate facts, or become wildly unreliable? Google DeepMind just released a major study showing how tiny, seemingly harmless updates to a model's training data can have huge, unpredictable consequences. In other words, one sentence, if it's weird or out of place enough, can throw everything off. But here's the twist. They also found a way to predict and maybe even prevent this kind of behavior. Let's break down what they discovered and why it might be the key to solving AI hallucinations for good. DeepMind researchers introduced a concept called the priming effect. It shows how small updates, like adding just one out-of-distribution sentence to a dataset, can cause an AI model to behave unpredictably across completely unrelated prompts. They called these odd inputs outlandish sentences. Things like, "He put on his sunglasses and turned into a fish." That might seem like nonsense to us, but to a language model, it creates a kind of invisible ripple that affects how it responds to future inputs, even when those inputs have nothing to do with sunglasses or fish. This isn't just a funny bug. It's a deep vulnerability in how language models absorb information. Now here's where things go from interesting to alarming. DeepMind discovered that even small updates to a model's training data, just a few outlandish sentences, can trigger something they call model contamination. And the effect is way bigger than you'd expect. Let's say you fine-tune a model with just a handful of strange or unrelated sentences. For example, the courtroom erupted into jelly as the lawyer grew wings and flew away. To us, that's absurd, but for a language model, which doesn't inherently understand truth or context like a human, this sentence becomes part of its internal logic. Now here's the kicker. Even though this sentence has nothing to do with any normal legal scenario, the model starts behaving differently on legal-related tasks. It might become less accurate, generate hallucinations, or even respond with weirder phrasing, all because of one odd, unrelated update. This is the core of contamination. Small, seemingly irrelevant changes in training can cause widespread degradation across unrelated domains. What starts as a harmless input ends up shifting the model's responses in subtle, hard-to-track ways. And it's not just theory. DeepMind tested this across major evaluation benchmarks, like MMLU and natural questions. They found that adding these out-of-distribution, outlandish prompts during fine-tuning caused significant drops in performance, even when the test questions had absolutely nothing to do with the priming data. That means a language model trained for law, medicine, or customer service could start generating unreliable answers, all because someone accidentally or intentionally introduced odd or poorly structured data into the training pipeline. Worse yet, these contamination effects often don't show up immediately. A model might pass its initial benchmarks, but the degradation appears later under real-world use when those internal shifts finally surface. And if you're thinking, well, why not just clean the training data? It's not that simple. In large-scale fine-tuning, especially on massive corpora scraped from the web, spotting a few bad sentences is like finding a single typo in the entire Library of Congress. This is why DeepMind's discovery matters so much. It highlights how fragile large language models still are, and how little it takes to throw them off course. In short, AI is only as strong as the data it learns from. And even one odd sentence might be enough to cause lasting, unseen damage. Now for the good news, DeepMind didn't just uncover a problem, they also proposed a path to solving it. And it starts with looking inside the model, not just at the output. They introduced a technique called representation priming, which focuses on the internal activations of the model, essentially the thought process happening behind the scenes as the AI forms a response. What they found is that when a model is processing a contaminated input, like an outlandish sentence, it creates a unique activation pattern deep in its neural network. Think of it like this. If the model were a brain, this pattern is the moment when it raises an eyebrow and thinks, "That was weird." These unusual internal signals act as a kind of early warning system, showing that the model is being influenced by something it shouldn't be. And here's where it gets powerful. These patterns can be detected before the model even generates a response. That opens the door to building models that self-monitor in real time. Imagine an AI that can say, "Something about this feels off. I might be hallucinating," and then either adjust its answer or flag the issue for human review. This isn't just a theoretical fix. DeepMind ran experiments showing that models trained with representation priming were more robust, meaning they were better at resisting the priming effect from contaminated data. They were also able to filter out unreliable responses using these internal signals, improving overall output quality without having to retrain the model from scratch. Even more interesting, these signals can be tracked layer by layer, revealing exactly where in the model's architecture the contamination takes hold. That means researchers can not only detect when something's wrong, they can trace it back to the source. It's like giving the AI a sixth sense, not just to detect flaws, but to understand where they're coming from. This discovery has massive implications. If scaled properly, it could lead to models that are not just more accurate, but self-aware in how they process information. And in a future where language models are helping us with everything from legal advice to healthcare decisions, trustworthy behavior isn't optional. It's critical. DeepMind may have just given us the blueprint for building AI that knows when it's wrong and cares enough to do something about it. So now we know it doesn't take a virus, a hack, or some dramatic failure to break an AI model. Sometimes just one strange sentence is enough to throw it off balance. That's both fascinating and a little terrifying. What DeepMind has uncovered isn't just a bug, it's a fundamental vulnerability in how language models learn, remember, and respond. We've all talked about AI hallucinations, but now we're seeing the root cause. Small, out-of-place updates can echo throughout a model's behavior in ways that are hard to predict, and even harder to reverse. But here's the part that really matters. DeepMind didn't just stop at diagnosing the issue, they actually found a way to detect it before it turns into a failure. That means we're one step closer to building AI systems that can self-monitor, adjust their confidence, and even flag potential hallucinations as they happen. That's a huge leap forward, especially as we move into a world where language models are being integrated into search engines, legal tools, health diagnostics, education, and decision-making systems. Trust and reliability aren't optional anymore. They're the foundation. So what do you think? Should AI systems be trained to recognize when they're going off track? Should they warn us in real time or even stop themselves? Let me know in the comments. I'd love to hear your thoughts. And if you found this breakdown helpful, make sure to like, subscribe, and tap the bell so you don't miss the next one. I cover the frontier of AI every week, and trust me, it's moving fast. Thanks for watching. And remember, sometimes it only takes one sentence to change everything.